And what is your C1, C2, C3? So C1, C2, C3, these are the solutions of the basically the given linear system of equation. So where this C1, C2 up to Cn, these are the solutions, these are solutions of the system of given this equation is double star, okay, which is given by this. So then this Z is a solution of this Ly equals to 0. And in addition, there is some initial constant that is ya at 1, y dash is e2, and so on. Okay, so this from the uniqueness theorem, there exists one and only one solution with these initial conditions. So by uniqueness theorem, we know that by this initial condition, this has a unique solution, which is already given in uh, Monday class. Okay. So here we can say that this is the unique solution and Zx be the solution of that. So this implies this Zx equals to Yx. So you can say that this completes our proof. So you can write here uh, in next page we can write this Z. Then Z is a solution of then Z is a solution of the Ly that equals to 0. And in addition, we have initial value, initial conditions are given. So these are your initial conditions. So yn minus a, that is an. These are the initial conditions. So from the uniqueness theorem, there is one and only one solution with these initial conditions. Okay, so that's why we can say that this is the solution of that, and this solution is the unique solution, and the solution of that is we can write Yx, so this equals to Yx for that interval. So this completes your proof. Okay, so in this sense, if we explore any I which is a subset of R, or we can, okay, R be an interval, and say if E be the subset of Rn, and let this f1, f2, say fn, these are the functions from I cross E means real R because x belongs to R, and here y1, y2, yn belongs to this Rn. So this is the mapping from this to real R. This be a given continuous function. This is the given continuous function. Okay, so if we consider a system of non-linear equations, and suppose y1 prime, this equals to f1 with a continuous function which is from x and y is from y1, y2 up to yn. So this is Rn and R plus 1. Say similarly y2 prime, this is f2 x y1 y2 to yn. Okay, so if we take yn prime, this is fn x1 x2 x1 x y1 y2 to yn. Okay, so this thing, and say if this is star, so we denoting this column vector y, this with component y1 y2 up to yn, and vector f with components f1 f2 up to fn. So the system of equation star is can be written as, the system can be written as uh, y prime is equals to function of fxy, where this y prime means this vector form. This can be written as something like y prime, and this if f be the vector form, so we can write this is the function. If f has component f1 f2 fn, so we can write this is x and y. Okay, or we can write this y prime is function of x y. This form where this y be the this vector and this f be this f1 f2 fn vector. Okay, so the a general nth order equation is representative in the form of, so this is basically the nth order differential equation. This nth order differential equation can be written as in this form, equation star. Okay, so which means that the study of nth non-linear differential equation is naturally embedded in the study of this simple form y prime equals to function of fxy. Okay, so in next page we write this all thing here. Next page we can write, if we denoting this basically column vector say y with components y1 y2 up to yn, and say another vector say f with components is f1 f2 up to fn. Okay, so the system of equation, this is star, this assumes the form. We can define this like y prime is function of fx y, where y the vector form which is component of y1 y2 up to yn here, and f be f1 f2 and fn form. Okay, so if we write in this form and we mark it equation the star, so a general nth order equation, a differential equation is represented in the form star, which means that the study of nth order non-linear equation this is actually embedded in the study. Okay, so this means if we study